Exit ticket 4.02. Line segment HG is grasped. Use a dotted line to indicate the line y equal 1. So, if I go to the origin, where does y equal 1? Y equals 1 here. Y equals 1 here and here and here. All of this is y equal 1. Y equal 1 is like a water level. That's where it is. After a reflection across the line y equal 1, so that's going to fall down, which point on H prime G prime, segment H prime G prime, has the smaller x coordinate? So we need to do the reflection. So we'll count to the line. 1, 2, 3, 4, 5, 6, 7 for H to the line, and then 7 again. 1, 2, 3, 4, 5, 6, 7. And there's H prime. G is closer to the line. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now, which has the smaller x coordinate? Well, here x equals 2, here x equals 9. So H prime has the smaller x coordinate, which is 2. That's the coordinate, and this is x equal 2. The coordinate is 2 comma negative 6, and H prime is the point that has it. All right, the second question. I'm going to do a little bit more on this question than the question asks, because I want to show the reflection that we're going to do. So triangle ABC is graphed. Which line reflection produces negative x and y coordinates of A prime, B prime, and C prime? This is ABC. So in what quadrant do we have negative x and negative y? That's down here in the third quadrant. So how can we reflect so that C comes down, B comes down, A comes down? So if we reflect over y equal x, that means reflect over a line like this. That means B's going up, A's coming down, C's coming down, and we're still in the first quadrant. So it's not y equal x. Y equal negative x is this line. And if we reflect over this line, then when we get to the other side, we're going to have coordinates in the third quadrant, which is what we want. So now let's figure out where they will go. So we said that when we're reflecting over a diagonal line, we should count diagonally for the reflection. So we've got diagonal 1, diagonal 2. Now be careful. Y equal negative x passes through the middle of this square. So we've got negative 1, we've got diagonal 1, diagonal 2, and a half. So then a half here, then 1, 2. So this is where C prime should be. Let's do the same thing with B. Diagonal 1, diagonal 2, diagonal 3, diagonal 4, exactly. So again, for diagonal. 1, 2, 3, 4. Then finally A. Diagonal 1, 2, 3, 4, 5, 6, and a half. We'll go half. 1, 2, 3, 4, 5, 6. So the reason I did this, to be honest with you, I haven't looked at, or I do not remember, the quiz that I'm going to give you on Monday. So I think it's quite likely that we'll ask you to deal with reflection over a diagonal line, so I wanted to show you that. Now really quickly, let's just, because this is the right answer, let's just show what happens with a reflection over y equals 0. So where does y equal 0? We've got y equal negative 10, y equal negative 5, y equals 0 here, and all along here is the level y equals 0. So if we reflect over y equals 0, that's the reflection from the first quadrant down to the second quadrant. Flipping here, flipping here, flipping here. x equals 0, so x equals 0 here, x equals 0 here, x equals 0 all along here. So if we reflect over x equals 0, then that's this reflection. Okay. Up here, the y values are positive. When the question asks, give me negative y values and negative x values. Great job, smarty pants. 2 more.